All right, you should have your worksheet in front of you that has 4 problems on it with A, B, C, and D, and we are going to work out 1 and 2, and you'll be responsible for 3 and 4. Part A says list all the possible rational zeros of your function. So we should remember that we learned about the p value and the q value. And so in order to do this, we should be thinking of the factors of 6, which are going to be plus and minus 1, plus and minus 2, plus and minus 3, and plus and minus 6. And also the factors of q, which is the leading coefficient of the polynomial, which would be plus and minus 1, plus and minus 2, and plus and minus 4. So in order to find the possible rational zeros, I need to take the ratios of all the p-values over the q-values. And so there's quite a few of those, so I'm going to take each of these p-values and divide it by each of the q-values. So I have plus and minus 1 over 1, plus and minus 2 over 1, plus and minus 3 over 1, and plus and minus 6 over 1. Then I'm going to take each of these and put them over 2. So I've got plus and minus 1/2, plus and minus 2/2, which we already have as plus and minus 1, plus and minus 3/2, and then plus and minus 6/2, which we already have. And finally, plus and minus 1/4, plus and minus 2/4, which we already have, plus and minus 3/4, which we don't, and plus or minus 6/4, which we already have right here. So those are all the possible rational zeros of the function. Part B, determine the number of real solutions. And I like to graph it. And when I graph this polynomial in a standard window, I find that the x-intercept here of 1 allows me to know that I have 1 real zero there. So I'm going to use that real solution and our synthetic factoring, or our synthetic division, and we're going to find the depressed polynomial in just a minute. So the number of real solutions would be 1. So we found in the last slide that x equals 1 was a solution, and that's a solution because if I plug in 1 into this polynomial, I get 0 out. So remember how synthetic division worked. We put all our coefficients in the matrix here, and then we brought down the 4, we multiplied, we added, we multiplied, we added, we multiplied, and we added. And we were left 1 degree lower than we began with. So I have a 4x squared plus 2x plus 6. And I have a sneaking suspicion that we are going to have a quadratic formula issue. So we're going to use the opposite of b, plus or minus the square root of b squared, minus 4 times a times c, all over 2a. Let's start the simplification process. So I say negative 2 plus or minus the square root of, this is 4 subtract 96, I believe. 24 times 4 is 96, so 4 minus 96 is negative 92. All over 8. And then I try to figure out how 92 will break down. So I'm going to say I use a little bit of I think I call it the ladder method. 2 goes into 9 4 times, carry the 1, and 2 goes into 12 6 times. 2 will also go in. 2 goes in 23 times, and then 23 is prime. So with that negative and also this prime factorization, I can have negative 2 plus or minus 2i on the root of 23 all over 8. And we're almost done. They'll each decrease or factor out a 2, So I would have negative 1 plus or minus I on the root of 23 all over 4. And that would be our final answer to find the depressed polynomial, and also, so this is the depressed polynomial, and also finding the remaining solutions, which we did right over here. The remaining imaginary solutions, which have come in a pair. Okay, number 2. List all the possible rational zeros of the function. So again, we have plus or minus 1, plus or minus 3, and plus or minus 9 here, and plus or minus 1. So let's find all the ratios of p to q. That leaves me with plus or minus 1, plus or minus 3, and plus or minus 9. That's not quite as many to list as the last one. Second part, determine the number of real solutions, which I like to graph. And so when I graph this one, I see that there's one place where we cross the x-axis again, so one real solution. And I see that x equals -1 makes this guy work, and so to double check, I guess, I'm going to double check by plugging in -1 everywhere x is, and I see that we get 0. So we're going to use that real solution and our synthetic division to be able to figure out the depressed polynomial. So here we go. Bring down the 1. Multiply, add, multiply, add, multiply, and add. So we're left with a polynomial, depressed polynomial of x squared plus no x's plus 9. And finally, part D asks us to use the quadratic formula to find the remaining solutions. So we said x squared plus 9. We want to find out when that equals 0. So we need to consider that C is 9 and A is 1 and B is 0. Okay? So the opposite of B would still be 0, plus or minus the square root of B squared, minus 4 times A times C, all over 2 times A, which equals 0 plus or minus the square root of -36 over 2, which is the same as plus or minus 6i over 2, which leaves us with plus or minus 3i. So we have our two remaining imaginary solutions as plus or minus 3i. In this case, we actually could have just subtracted 9 and square rooted both sides and gotten x is equal to plus or minus 3i. But just be careful, because if we have a middle term, the linear term, you can't do it that way. All right, so as I said in the beginning, you are responsible for number 3 and 4.